Guys, in this video we are going to discuss solutions of prac class 6b, right? So let's discuss this one here. Write down the main advantages of bisection method while you are mentioning disadvantages of bisection method. So what are the advantages? We go to our notes. You can mention that the bisection method is always convergent. So you can mention that one. That is a good thing, right? So if you consider any continuous function, you can find roots using bisection method, right? So even though it is very slow to converge, but bisection method is always convergent, right? So, and you can note that this is one of drawbacks. So bisection method is very slow to converge, right? You can mention that one also. And there's another drawback of bisection method. You need 2 points to evaluate the root of a function. So you need 2 points, right? And another one, if f of x touches the x-axis, so that one is unable to find the interval such that f of a times f of b is negative. You know that the product of f of a and f of b is negative. Then you can say that there's a root in between a and b, right, in a b interval. So, but if the function touches the x-axis like this, it is difficult to find a-b interval, right? That is a drawback of bisection method. Now let's move to the second question. Show that this function has a root in this interval. So all you need to do is substitute these points separately. Find f of 1. Look at the sign of that. F of 1 and f of 2. Right? If one of them is positive and another one is negative, the product is negative. Then you can say that there exists a root, at least a root in 1, 2 close interval, right? Right, you can do that. And the next one, use the bisection method to determine an approximation to the root that is accurate to at least within the relative error 10 to the minus 4. So let's do that part. So just notice this part here, this bit. So determine an approximation to the root that is accurate to at least within the relative error, right? Relative error 10 to the minus 4, right? Okay, let's do that. So this is the algorithm of bisection method, right? Our function is continuous. Here, this is our function. This is our function. This is the interval. This function is continuous in this interval, right? Then find point A and B. A is equal to 1 and B is equal to B. Right? B is equal to 2. Right? Then check this condition is true. You can check that one. You can evaluate f of 1 and f of 2 and take the product of these two quantities and look at the sign. Whether it is negative, then you can say that there exists a root in between A and B, right? Let's denote P sub 1, the first root, because we iterate this one. So P sub 1 is a root in between A and B, such that, alright, and we take the midpoint of that. The midpoint of 1 and 2 is 1 plus 2 divided by 2, which is 1.5 is the midpoint. Alright, midpoint. We take P sub 1 is our first midpoint, 1.5. If this one is equal to 0, then P1 is an exact root. Otherwise we check whether this product is negative or other one is negative. If this one is negative, we choose other n, A is equal to P1, like that. I think you are familiar these steps. You know how to use bisection method, right? So let's do this one, do this process. Here, look at this graph here. This is the exact root. This is your continuous function. This is your A, B. First you find the midpoint of A and B. So A sub 1 is A, B sub 1 is B. Then you find the midpoint P1, which is same with this A sub 1 is same with so this is the midpoint, right? P sub 1. Then you check the sign product of F sub P1. So this one here, this function is f of P sub 1, and this one is f of A. You take the product, definitely the product is negative, and that means there's a root in between these two. Then we take, this is our B, and we divide this interval. We divide this interval into two subintervals like this, and this is the midpoint of these two, this interval, right? And P2 is the midpoint of A sub 1 and B sub 1, like that, right? We divide subintervals, two equal size two subintervals, right? So this is the stopping criteria, right? This is the stopping criteria. The top one here is the absolute error. So this one is the previous midpoint, and this is the current midpoint. We take the difference between previous and current and take the modulus, and if you divide it by the current midpoint, you get the relative error. So our one here, so use the bisection method to determine an approximation to the root that is accurate to at least this within this relative error. Then this should be less than 10 to the power minus 4, right? This is our relative error. So all the time you have to compute, you can compute P1, P2, P3, P4, then you can find the difference here. So this is P1, can find that, which is P1 is the midpoint of initial interval AB. P1 is average of A plus B divided by 2. And P2, you can find P2, can compute that, P3, P4 like that, right? Then you can find this one, absolute error, by taking the distance between these, difference between these two quantities, and take the modulus of that divided by the current one, right? That should be less than 10 to the power minus 4, right? Look at this. This is f of 1, which is negative 5. F of 2 is 14. The product of these two is negative. That means using the intermediate value theorem, you can say that there exists a root in between 1 and 2, because f is continuous, right? Now you consider the midpoint of these two. 1 plus 2 divided by 1 plus 2 is 3, divided by 2 is which is 1.5. Then you find the function value at the midpoint, which is this. Then you, so this is your midpoint, right? This is your midpoint, 1.5, and here you have 1, here you have 2, you have function value. These are the function values, 2 point something right here at 1.5, 2.3. So the function value is function value at this point is 2.375 here, which is positive, and the function value at this point is negative 5, and function value at this point is positive 14 here. So this is positive, this is negative. That means because f is a continuous function, then you send the real root in between these two intervals, this interval. Then we select B as 1.5, right? This is your A value. Then you can find the midpoint. You can find the midpoint of these two, right? So what is the midpoint? The average of 1 and 1.5, and so you get something like 1.25. This is the midpoint. Then you find the function value at this point. This is the function value at that point, which is negative. This one is negative, positive, right? But here this is negative value, this one, and this is a positive value. Then you consider these two subintervals. Then you divide this subinterval into two equal subintervals. You find the midpoint of this one and this. So 1.5, you consider 1.25 and 1.5 subinterval. Then you can find the midpoint of these 2 points, which is here. So this is the subinterval, new interval, our new interval, and midpoint of these two numbers is this, 1.375. So we continue this, we carry on this process until we get what is the stopping criteria. Until we get this condition, we set, so this, if this condition satisfies, we stop our iteration, right? So first one is 1.5, first midpoint is 1.5, second one is 1.25, third one is 1.3 something. Yeah, third one is 1.375. You look at this table here, this is the first iterative, and A is 1, initial endpoint, left end, this is right end 2, and midpoint of these 2 points is 1.5, and the function value at this point is -5. Function value at the midpoint is this. Positive, negative. Then definitely next, the exact root in between these two numbers, and also you can find the relative error. This one here, look at this one. This is the initial step, and this is the first midpoint. P sub 1, P sub 2, P sub 3, P sub 4, P sub 5, like that, right? Then if you have P sub 1 and P sub 2, then you can find the relative error, this one, right? Relative error, use this. So according to this equation, you can find the relative error, the current midpoint minus the previous midpoint divided by the current one. Then you get the relative error. Like that, you can find these relative errors, right? Look at this. This one here, this relative error is less than 10 to the power minus 4. Then the root, so you can choose, this is the root to that